Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to learn about the relation between the coefficients and the zeros of a quadratic polynomial. So see here, how can we relate the coefficients and the zeros of the polynomial? First we have quadratic polynomial. So see here, how can we relate the coefficients and the zeros? So first I am going to explain an example here. See here, let p of x is equal to x square plus 7x plus 10. So this is a quadratic polynomial. So here the coefficient of x square is how much? 1. And the coefficient of x is 7. The constant term is 10. Coefficient of x square is 1, coefficient of x is 7, and the constant is 10. So now we have to find the zeros of the quadratic polynomial. So how can we find? Let p of x is equal to 0. Let p of x is equal to 0. That implies we can get x square plus 7x plus 10 is equal to 0. So now we have to find the factors by splitting the middle term. So here the x square coefficient is 1, constant is 10. So 1 into 10 is 10. So now we have to select two factors for 10. Their product should be 10 and their sum should be 7. So 2 into 5 is 10. 2 into 5 is 10. 2 plus 5 is 7. Therefore, we can write x square plus 2x plus 5x plus 10 is equal to 0. X is common here. X plus 2, again plus 5 is common. We can get x plus 2 is equal to 0. Totally x plus 2 is common. X plus 2 into x plus 5 is equal to 0. We can get x plus 2 equal to 0 or x plus 5 is equal to 0. So we have x is equal to minus 2 or x is equal to minus 5. So minus 2 and minus 5 are the zeros of the quadratic polynomial x square plus 7x plus 10. So now we have to find the relation between the zeros and the coefficients. So see here, I want to find the sum of the zeros. So here sum of the zeros is equal to. So here these two are the zeros. We have to find the sum, that is minus 2 plus minus 5. So minus 2 minus 5 is equal to how much it is? Minus 7. Minus 2 plus minus 5 is equal to minus 7. So now we have to relate the sum of the zeros with the coefficients. So write minus, it is 7 is nothing but what it is? 7 is the coefficient of x. 7 is what? Coefficient of x. Minus coefficient of x. Coefficient of x divided by here minus 7 can be written as I am writing here minus 7 divided by 1. Minus 7 divided by 1. This 1 is nothing but the coefficient of x square. Coefficient of x square. Coefficient of x square. Coefficient of x square. So here we can relate sum of the zeros. Sum of the zeros of a quadratic polynomial is equal to minus of coefficient of x divided by coefficient of x square. So this is sum of the zeros. We can relate product of the zeros also. So see here, how can we relate product of the zeros? So here zeros are minus 2 and minus 5. Their product is minus 2 into minus 5, which is equal to plus 10. Minus 2 into minus 5 is plus 10. So I am writing 10 is 10 by 1 again. 10 by 1 is nothing but 10 only. So now this 10 is what? 10 is the constant term in the given polynomial. So we can write constant term divided by 1 is again coefficient of x square. 1 is what? Coefficient of x square. Coefficient. So this you have to remember. For a quadratic polynomial, sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square, and the product of the zeros is equal to constant term divided by coefficient of x square. So these two things you have to remember. So this is the example. See here, very easy. Sum of the zeros is equal to how much? Minus 2 and minus 5 are the zeros of the quadratic polynomial x square plus 7x plus 10. Sum of the zeros is minus 2 plus minus 5, that is minus 7. So minus 7 can be written as minus 7 divided by 1. Here minus 7, that is right, minus as usual. This 7 is coefficient of x. Yes, it is coefficient of x. Divided by this 1 is coefficient of x square. Yes, coefficient of x square is 1. In the same way, product of the zeros equal to, so zeros are minus 2 and minus 5. Their product is minus 2 into minus 5 is equal to plus 10. 10 can be written as 10 divided by 1. Here 10 is what? A constant term. Divided by 1 is coefficient of x square. Here the coefficient of x square is 1. So like this we can relate the zeros and the coefficients of the quadratic polynomial. So now in general, how can we write in the formula? Now we have to see here, let alpha comma beta are the two zeros of a quadratic polynomial ax square plus bx plus c. Then sum of the zeros alpha plus beta is equal to, so let alpha comma beta are the zeros of the quadratic polynomial ax square plus bx plus c. So what is the degree of the quadratic polynomial? Here it is 2. So it has 2 zeros. So let the two zeros of this quadratic polynomial as alpha and beta. So now sum of the zeros equal to alpha plus beta is equal to a minus of coefficient of x divided by coefficient of x square. A minus of coefficient of x divided by coefficient of x square. So here observe, what is the coefficient of x? B is the coefficient of x, but minus is there, is equal to minus b. Minus of coefficient of x, that is minus coefficient of x is b, that is minus b divided by coefficient of x square. Here the coefficient of x square is a, so we can write minus b by a. Simply you have to remember that sum of the zeros of a quadratic polynomial alpha plus beta is equal to minus b by a. So minus b by a. So in the same way, product of the zeros equal to alpha into beta is equal to constant term divided by coefficient of x square. So here what is the constant term? C is the constant term, that is c divided by coefficient of x square is a again. So c by a. So you have to remember that product of the zeros alpha into beta is equal to c by a. C is the constant term, a is the coefficient of x square. So these two things you have to remember. See here once again, let alpha comma beta are the two zeros of the quadratic polynomial ax square plus bx plus c. Then sum of the zeros alpha plus beta equal to minus b by a. Product of the zeros alpha into beta equal to c by a. So these two things you have to remember. So next we have to find the quadratic polynomial if he gives sum of the zeros and the product of the zeros. How can we find the quadratic polynomial? So see here, if he gives the roots of the quadratic polynomial and sometimes he asks to find the quadratic polynomial. He gives the roots and he asks to find the quadratic polynomial. And sometimes he gives the sum of the roots and product of the roots, he asks to find the quadratic polynomial. So for that we have to remember this formula. See here what it is. Let in general alpha and beta are the zeros of the quadratic polynomial P of x is equal to ax square plus bx plus c. A is not equal to 0. Then x minus alpha and x minus beta are the factors of P of x. So if alpha comma beta are the roots, then x minus alpha and x minus beta becomes the factors. So now we can write, therefore ax square plus bx plus c is equal to k into x minus alpha into x minus beta. Here k is constant, k is equal to constant. So we use this formula to find the quadratic polynomial if he gives the roots of the polynomial. Suppose if he gives alpha value and beta value, he is asking to find the quadratic polynomial. We use this formula, k into x minus alpha into x minus beta. If he gives alpha and beta value, we have to use k into x minus alpha into x minus beta to find the quadratic polynomial. Sometimes he gives sum of the roots and the product of the roots to find the quadratic polynomial. In that case, see here, if we multiply these two, we can get k right as usual. X square minus alpha plus beta into x plus alpha into beta. So here alpha plus beta is nothing but sum of the roots into x plus alpha beta is product of the roots. Suppose if he gives the values of sum of the roots and product of the roots to find the quadratic polynomial, we have to use the formula. So the required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. Or we can say like this, k into x square minus sum of the roots into x plus product of the roots. So very important, these two formulas you have to remember to do the problems in the next exercise 3.3. So only two formulas you have to remember. Once again, if alpha comma beta are the roots of the quadratic polynomial, then we have to find the quadratic polynomial. So it is quadratic polynomial is equal to k into x minus alpha into x minus beta. So that is the formula. Next, second one, if he gives a sum of the roots and the product of the roots, we use this formula. A required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So these two formulas you have to remember. See once again what I have written. In general, alpha and beta are the zeros of the quadratic polynomial. P of x equal to x square plus bx plus c. A is not equal to 0. Then x minus alpha and x minus beta are the factors of P of x. Therefore ax square plus bx plus c is equal to k into x minus alpha into x minus beta. K is constant. So if we multiply these two, we can get k into x square minus alpha plus beta into x plus alpha into beta. So here alpha plus beta is sum of the roots, alpha into beta is product of the roots. So this is the relation between the coefficients and the zeros of the quadratic polynomial. And next we have to write the relation between, we have to learn about the relation between the zeros and the coefficients of the cubic polynomial. So now we have to find the relation between the coefficients and the zeros of a cubic polynomial. So let alpha comma beta and gamma are the zeros of a cubic polynomial. P of x is equal to ax cube plus bx square plus cx plus d. Then sum of its zeros alpha plus beta plus gamma is equal to again minus of coefficient of x square divided by coefficient of x cube, that is minus b by a, and product of its zeros is equal to alpha into beta into gamma equal to a minus of constant term divided by coefficient of x cube, that is minus d by a. So see here how can we write what it is. See here, in general, if alpha comma beta and gamma are the zeros of the cubic polynomial, P of x equal to ax cube plus bx square plus cx plus d, then sum of its zeros alpha plus beta plus gamma is equal to minus of coefficient of x square divided by coefficient of x cube is equal to, right, minus coefficient of x square. Here the coefficient of x square is b divided by coefficient of x cube. Here the coefficient of x cube is a is equal to minus b by a. In the quadratic polynomial also sum of the zeros alpha plus beta equal to minus b by a, but there b is the coefficient of x, but here b is the coefficient of x square, that you have to remember. There a is the coefficient of x square, but here a is the coefficient of x cube. So the difference you have to remember, don't confuse. So next, product of its zeros alpha into beta into gamma is equal to a minus of constant term divided by coefficient of x cube. Here a constant term is d, so that is minus d divided by, again, coefficient of x cube is a. So these two things you have to remember, and also we can relate alpha beta plus beta gamma plus gamma alpha is equal to c by a. C is the coefficient of x divided by a is the coefficient of x cube. So these three things you have to remember. See once again, if alpha, beta and gamma are the zeros of a cubic polynomial ax cube plus bx square plus cx plus d, then sum of its zeros alpha plus beta plus gamma is equal to minus b by a. Product of its zeros alpha into beta into gamma is equal to minus d by a. Next, third one, alpha into beta plus beta into gamma plus gamma into alpha is equal to c by a. So these three things you have to remember to do problems in the next exercise 3.3. Next we have to do problems from 3.3 exercise. See problems from 3.3 exercise. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from Polynomials exercise 3.3 first problem. So see here what he is asking to find us. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So already we have learned the relation between the zeros and the coefficients of a quadratic polynomial. So now he has given a quadratic polynomial. First he is asking to find the zeros and verify the relationship between the zeros and the coefficients. So first you have to find the zeros. So see here how can we find. This is the given quadratic polynomial x square minus 2x minus 8. So in the first problem there are totally 6 bits. This is the first bit. So one by one we have to solve. See here, first one x square minus 2x minus 8. So to find the zeros, let the given polynomial is equal to 0. So we have x square minus 2x minus 8 is equal to 0. Okay, so let it is equal to 0. So now we have to find the factors by splitting the middle term. For that the coefficient of x square is 1 and the constant is minus 8. 1 into minus 8 is minus 8. Now we have to select two factors for minus 8. Their product should be minus 8, their sum should be minus 2. So I am selecting 4 into minus 2, minus 4 into 2, that is minus 4 into 2 is minus 8, minus 4 plus 2 is minus 2. So these two are the factors. So now I am writing, see here, write x square as usual, but this minus 2x write as minus 4x plus 2x. So I am writing minus 4x plus 2x minus 8 is equal to 0. So in the first two terms x is common. So I am taking x as common. We get x into x minus 4. If you take x here, x will be again here minus 4 will be. In these two plus 2 is common. Plus 2 into here x, here minus 4. So 8 can be written as 2 into 4, 2 is common, again 4 will be is equal to 0. So again in these two terms x minus 4 is common. So take x minus 4 as common. So here x is there and here plus 2 is there. So x minus 4 into x plus 2 is equal to 0. From this we can write x minus 4 is equal to 0 or x plus 2 is equal to 0. So from these two we can get x is equal to 4 or x is equal to minus 2. So 4 and minus 2 are the zeros. Therefore zeros equal to, therefore the zeros of x square minus 2x minus 8 equal to minus 2 and 4, minus 2 and 4. So these are the zeros. So after finding the zeros, he is asking to verify the relationship between the zeros and the coefficients. So verification, how can, so now we have to find the sum of the zeros, So see, so sum of the zeros, that is minus 2 plus 4, minus 2 plus 4 is 2. So 2 by 1, 2 I am writing as 2 by 1. This 2 I am writing minus of minus 2 divided by 1. I have written plus 2 as minus of minus 2. So I am writing this minus as usual. But this minus 2 is what? Coefficient of x. I am writing as coefficient of x. Coefficient of x divided by, this one is nothing but coefficient of x square, coefficient of x square. So here sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square, that is minus 2 plus 4 is plus 2. Plus 2 can be written as 2 by 1, but this plus 2 I have written is minus of minus 2 divided by 1. So this minus, right, as usual, this minus 2 is coefficient of x divided by 1 is coefficient of x square. So simply we can write this is sum of the zeros. In the same way, product of the zeros is equal to product of the zeros. So that is minus 2 into plus 4, product of the zeros, minus 2 into 4, which is minus 8. Minus 2 into 4 is minus 8. This I am writing as minus 8 can be written as minus 8 by 1. Minus 8 by 1. So this is nothing but a constant term divided by minus 8 is the constant term of the given quadratic polynomial and 1 is the coefficient of x square. 1 is what? Coefficient of x square. So now we have verified the relationship between the zeros and the coefficients. We know sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square. Product of the zeros is equal to constant term divided by coefficient of x square. Therefore verified between the coefficients and the zeros of the given quadratic polynomial. So this is the first bit in the first problem. So next we have to solve the second bit. This is the second bit in the first problem. Again we have to find the zeros of the given quadratic polynomial. Then we have to check the relation between the zeros and the coefficients of the given quadratic polynomial. So here 4s square minus 4s plus 1 is given. So see here, let the given polynomial be 0. We have, so let 4s square minus 4s plus 1 is equal to 0. So now we have to find the factors by splitting the middle term. Here the coefficient of s square is 4 and the constant is 1. 4 into 1 is equal to 4. So now we have to select two factors for 4. Their product should be plus 4 but their sum should be minus 4. Here we have to take minus 2 into minus 2 is equal to plus 4. Minus 2 plus minus 2 is equal to minus 4. So now we can write 4s square right as usual, but this minus 4 can be written as minus 2s plus 1 equals to 0. So now in these two, 2s is common, so take 2s as common. So again 2s will be 2s minus 1. In these two, minus 1 is common, again 2s minus 1 is equals to 0. So now 2s minus 1 is common, so 2s minus 1 is common. Again we have 2s, here also minus 1 is equals to 0. We can get 2s minus 1 equal to 0 or 2s minus 1 equals to 0. Then we can get a 2s minus 1 equal to 0 or 2s minus 1 equal to 0. So take minus 1 to the right side, it becomes 2s equal to 1 or 2s equal to 1. Take 2 to the right side, we get s equal to 1 by 2 or s equal to 1 by 2. So here therefore zeros of 4s square minus 4s plus 1 equal to 1 by 2 and 1 by 2. It has two equal zeros, 1 by 2 and 1 by 2. So now I have to verify the relationship between the zeros and the coefficients. Here sum of the zeros is equal to 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is equal to 1. So here this 1 I am writing as minus of minus 4 divided by 4 I have written. So here 1 can be written as 4 by 4. 1 can be written, I am writing 1 as 4 by 4. But this plus 4 I have written as minus of minus 4 divided by 4. So see here why I have written like this. So sum of the zeros, we have sum of the zeros equal to minus of coefficient of x divided by coefficient of x square. But here variable is s. We can write sum of the zeros is equal to minus of coefficient of s divided by coefficient of s square. So for that I have written here minus of minus 4 divided by 4, minus into minus plus 4 by 4 we can get cancel, again we get 1. So minus of minus 4, minus of this minus 4 is nothing but coefficient of s, minus 4 is coefficient of s. Again this plus 4 is coefficient of s square. Yes, coefficient of s square is plus 4. So here sum of the zeros is equal to minus of coefficient of s divided by coefficient of s square. So next product of the zeros is equal to 1 by 2 into 1 by 2. 1 by 2 into 1 by 2 is equal to 1 by 4. 1 by 4. So here 1 by 4. 1 is nothing but constant term. 1 is the constant term. 4 is the coefficient of s square. Yes, here 4 is the coefficient of s square. Therefore, we have product of the zeros is equal to constant term divided by coefficient of s square. Yes, here it is coefficient of s square. Therefore, we can write verified. So here verified. So now we have found the zeros of the given quadratic polynomial 4s square minus 4s plus 1. The zeros of 4s square minus 4s plus 1 is equal to 1 by 2 and 1 by 2. So verification, sum of the zeros is equal to minus of coefficient of s divided by coefficient of s square. Product of the zeros equal to constant term divided by coefficient of s square. So this is the second bit in the first problem. Next we have to solve the third bit. This is the third bit in the first problem. It has given 6x square minus 3 minus 7x. Again we have to find the zeros of the given quadratic polynomial. Then we have to find the verify the relationship between the zeros and the coefficients. So here 6x square minus 3 minus 7x he has given, but here it is not in its standard form. First we have to write in its standard form. So we have 6x square minus 7x minus 3. First we have to write x term, x square, next x term, next constant term. So this is the standard form. So the powers of the variable should be in the decreasing order. So here 2 1 0. So now it is in its standard form. So to find the zeros, let the given polynomial is equals to 0. So let 6x square minus 7x minus 3 equal to 0. Now how to find the factors? By splitting the middle term. For that, coefficient of x square is 6, constant is minus 3. How to multiply? 6 into minus 3 is equal to minus 18. So now we have to select the factors for 18. Their product should be 18, sum should be minus 7. So now I am taking 2 into minus 9 is 2 into minus 9 equal to minus 18. 2 plus minus 9, that is 2 minus 9 equal to minus 7. So these two are the factors. So how can we write? See here, write 6x square as usual. But this minus 7x can be written as plus 2x minus 9x minus 3 equal to 0. So write 6x square as usual, but only minus 7x can be written as 2x minus 9x. Again write minus 3 as usual is equals to 0. In first two terms 2x is common. I am taking 2x as common. So if you take 2x as common, here 3x will be. So here 2x is common, only 1 will be. So again if you multiply 2x into 3x, 6x square, 2x into 1, 2x. In these two, minus 3 is common. Only minus 3 is common. We can get here 3x plus 1 equals to 0. So here again if you multiply with minus 3 into 3x minus 9x, minus 3 into plus 1 is minus 3. So in these two 3x plus 1 is common again. So I am writing 3x plus 1 into 2x minus 3 equals to 0. So now we can write either 3x plus 1 equals to 0 or 2x minus 3 equals to 0. So by taking plus 1 to the right side, we get 3x is equal to minus 1, or here 2x is equal to plus 3. So here x is equal to minus 1 by 3, or here x is equal to 3 by 2. So now these two are the zeros of the given quadratic polynomial. Therefore zeros of 6x square minus 7x minus 3 is equal to minus 1 by 3 and 3 by 2. So now we have to verify the relationship between the zeros and the coefficients of the given quadratic polynomial. So for that we have to find sum of the zeros is equal to minus 1 by 3 plus 3 by 2. So find LCM. So 6 is the LCM here. You can get to minus 2 and plus 9. 2 3s are 6, 3 3s are 9. So minus 2 plus 9 is 7 by 6. 7 by 6. So I am writing this 7 by 6 as so here minus of minus 7 divided by 6 is equal to. So here see here sum of the zeros is equal to minus 1 by 3 plus 3 by 2. We have to find LCM. So 6 is the LCM here. If you divide 3 by 6, you can get 2. 2 into minus 1 is minus 2. Next, if you divide 6 by 2, you can get 3. 3 into 3 is 9. Minus 2 plus 9 is plus 7 divided by 6. But this 7 I have written as minus of minus 7. So again, if minus into minus, we can get plus 7. So minus of minus 7 divided by 6. So it is equal to minus of, this minus 7 is nothing but coefficient of x. So minus 7 is what? Coefficient of x divided by this 6 is coefficient of x square. 6 is what? Coefficient of x square. So sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square. In the same way, you have to find the product of the zeros. So that is a product of the zeros equal to minus 1 by 3 into 3 by 2. Minus 1 by 3 into 3 by 2. So minus 1 into 3 is minus 3 divided by 3 into 2 is 6. So now here product of the zeros is we have constant term divided by coefficient of x square. So here this minus 3 is what? Constant term here. Minus 3 is the constant term divided by 6 is what? Coefficient of x square. 6 is coefficient of x square. Yes, therefore we have to write verified. Therefore verified the relationship between the coefficients and the zeros of the given quadratic polynomial. So this is the third bit. Once again, see here, this is the given polynomial. It is not in its standard form. First we have to write in its standard form. So zeros of the given polynomials are minus 1 by 3 and 3 by 2. So sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square, and the product of the zeros is equal to constant term divided by coefficient of x square. So therefore verified. So this is the third bit in the first problem. Next we have to solve fourth bit. This is fourth bit in the first problem. 4u square plus 8u has given. Again we have to find the zeros of the given quadratic polynomial. Then after we have to verify the relationship between the zeros and the coefficients. So first we have to find the zeros. So for that we have let 4a square plus 8u is equal to 0. So in these two, here there is no constant term. Very easy to find the zeros. So let 4u square plus 8u is equal to 0. In these two 4u is common. I am taking 4u as common. So here only u here plus 2 will be equal to 0. So I have taken 4u as common. Again if you multiply 4u into u, 4u square, 4u into 2, 8u. So here 4u is equal to 0 or u plus 2 is equal to 0. So from this we can get u is equal to 0 by 4, that is 0, or u is equal to minus 2. Therefore the zeros of 4u square plus 8u is equal to 0 and minus 2. 0 and minus 2. These two are the zeros. So now we have to find sum of the zeros, that is 0 plus minus 2 is equal to minus 2. But this minus 2 I am writing as so see here how can we write this minus 2? Minus of 8 divided by 4. 8 divided by 4. I am writing this minus 2 as minus 8 divided by 4. Again if you cancel by 4, 4 ones and 4 twos, we get minus 2. Why I have written minus 8 by 4? So here the formula is sum of the zeros is equal to minus of coefficient of u divided by coefficient of u square. So here minus of 8 is coefficient of u. Yes, here the coefficient of u is 8. Coefficient of u square is 4. Coefficient of u square is 4. Yes, this 4 is coefficient of u square. So sum of the zeros is equal to minus 2, that is minus 8 by 4. So minus coefficient of u divided by coefficient of u square. So in the same way product of the zeros equal to 0 into minus 2, that is 0. So 0 I am writing as 0 divided by 4. So see here, 0 into minus 2, zeros, product of the zeros is 0 into minus 2 is 0, 0 I have written as 0 by 4, since constant term divided by coefficient of a square. Here there is no constant term, we can write the constant term as 0 and the coefficient of u square is 4. So 0 by 4 is also 0 only. So like this we can verify product of the zeros equal to constant term divided by coefficient of u square. So therefore verified. So we have verified the relationship between the zeros and the coefficients. So this is the fourth bit in the first problem. Next we have to solve the fifth bit. This is fifth bit in the first problem, t square minus 15. We have to find the zeros of t square minus 15, and also we have to verify the relationship between the zeros and the coefficients. So for that, see here we have let t square minus 15 is equal to 0. Here there is no t term. So there are only t square term and the constant term. Now it is very easy to find the roots or zeros. So see here how can we find this, write t square as usual minus this 15 I am writing as square root 15 whole square, square root 15 whole square equal to 0. So now it is in the form a square minus b square. A square minus b square is equal to a plus b into a minus b. So we can write it is t plus root 15 into t minus root 15, t minus root 15. So it is in the form a plus b into a minus b. Therefore we can write t plus root 15 equal to 0 or t minus root 15 is equal to 0. So from this we can write take plus root 15 to the right side, that is t is equal to minus root 15 or t is equal to plus root 15. Minus root 15 becomes plus root 15. Therefore zeros of t square minus 15 is equal to t square minus 15 is equal to minus root 15 and plus root 15, minus root 15 and plus root 15. So now we have found the zeros. So next we have to verify the relationship between the zeros and the coefficient. For that first we have to find the sum of the zeros. Sum of the zeros is equal to minus root 15 plus root 15. So it becomes 0. So here 0 I am writing as 0 divided by 1, which is equal to, here 0 is minus of coefficient of t. Here there is no t term, coefficient of t is 0 divided by coefficient of t square is 1. So 0 by 1 is again 0. So sum of the zeros is equal to 0, that we can relate minus of coefficient of t divided by coefficient of t square. There is no t term, hence we can write 0. So next product of the zeros is equal to minus root 15 into plus root 15. So root 15 into root 15 is equal to minus 15. So I am writing as minus 15 is equal to minus 15 divided by 1. So minus 15 divided by 1. So we have to verify the relation. This minus 15 is constant term. Constant term divided by 1 is coefficient of t square. Coefficient of t square is 1. Therefore product of the zeros equal to constant term divided by coefficient of t square. Therefore verified. Therefore verified. So this is the fifth bit in the first problem. So just we have to remember sum of the zeros equal to minus of coefficient of t divided by coefficient of t square. Product of the zeros equal to constant term divided by coefficient of t square, since here the variable is t. So this is the fifth bit in the first problem. Next we have to solve the sixth bit. this is the sixth bit in the first problem. Totally there are 6 bits. We have completed 5 bits. This is sixth bit. 3x square minus x minus 4. First we have to find the zeros of 3x square minus x minus 4. Then after we have to verify the relationship between the zeros and the coefficients. So for that we have let 3x square minus x minus 4 equal to 0. We have to find the factors by splitting the middle term. For that, multiply the coefficient of x square by the constant term. Here the coefficient of x square is 3 and the constant term is minus 4. 3 into minus 4 is equal to minus 12. So in the same way, so these two are the factors itself. 3 minus 4 is minus 1. So these two are the factors again. 3 minus 4 equal to minus 1. Here the coefficient of x is minus 1. So see here how can we write 3x square. This minus x can be written as plus 3x minus 4x. Write this minus 4 as usual. So in these two 3x is common. So I am writing 3x as common. So here only x will be. Here plus 1 will be. In these two minus 4 is common. So here x will be. Here plus 1 will be is equals to 0. So in these two terms x plus 1 is common. So write x plus 1 into. So here 3x will be. Here minus 4 is there. 3x minus 4 equals to 0. So either x plus 1 is equals to 0 or 3x minus 4 equals to 0. So here x is equal to minus 1 or here 3x equal to 4. That implies x is equal to 4 by 3. X is equal to 4 by 3. Therefore zeros are minus 1 and 4 by 3. Therefore zeros of 3x square minus x minus 4 is equal to minus 1 and 4 by 3. Minus 1 and 4 by 3. So now I have to verify the relationship between the zeros and the coefficients. For that, first we have to find the sum of the zeros. So we know sum of the zeros equal to minus of coefficient of x divided by coefficient of x square. So sum of the zeros is equal to minus 1 plus 4 by 3. So find LCM. So we can get minus 3 plus 4 divided by 3, that is 1 by 3. 1 by 3. So now we have to check this 1 I am writing as minus of minus 1 divided by 3. So plus 1 I have written as minus of minus 1. So to verify the formula, sum of the zeros equal to minus of coefficient of x divided by coefficient of x square. So for minus minus, so this coefficient of x is minus 1 is there here. Once you check, yes, coefficient of x is minus 1 divided by coefficient of x square is 3 is there. Yes, here also coefficient of x square is 3. Therefore sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square. Next we have to verify product of the zeros. So product of the zeros is equal to minus 1 into 4 by 3. Minus 1 into 4 by 3 is minus 4 divided by 3. Minus 4 divided by 3. So here that is product of the zeros is we have constant term divided by coefficient of x square. Here the constant term is minus 4. Yes, verify, here the constant term is minus 4. Here 3, coefficient of x square is 3. Yes, verify, here the coefficient of x square is 3. Therefore verified the relationship between the coefficients and the zeros. So now this is sixth bit in the first problem. So we have completed all the 6 problems. So in the next class we will do the second problem. So see here, just you have to remember the formula. Sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square. Product of the zeros is equal to constant term divided by coefficient of x square. these two formulas you have to remember, you can do very easily. So we have completed all the 6 bits in the first problem. So that's all today's class. We will meet in the next class with another problem. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from Polynomials exercise 3.3, second problem. So already we have completed first one. See here what he is asking to find us. Find the quadratic polynomial in each case with the given numbers as sum and product of its zeros respectively. So here he has given sum of the zeros and product of the zeros. He is asking to find us the quadratic polynomial. So we know the formula. If the sum of the zeros is alpha plus beta and the product of the zeros is alpha into beta, then the quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So this is the formula. So just we have to substitute alpha plus beta value and alpha into beta value, we can get the required quadratic polynomial. So see here, sum of the zeros he has given, sum of the zeros. So this is first bit and the second problem. Totally there are 6 bits, you have to solve one by one. So first bit 1 by 4 comma minus 1. So 1 by 4 is the sum of the zeros, minus 1 is the product of the zeros. So sum of the zeros is equal to, so it is denoted by alpha plus beta. So alpha plus beta is equal to 1 by 4 he has given. So and he has given product of the zeros and product of the zeros product of the zeros, so product of the zeros is denoted by alpha into beta, which is he has given minus 1. Therefore the required quadratic polynomial is equal to required quadratic polynomial. So what is the formula? K into x square minus alpha plus beta into x plus alpha into beta. So where k is constant, k is equal to what? Constant. So this is the formula, required quadratic formula. So required quadratic formula is equal to k into x square minus alpha plus beta into x plus alpha into beta. We know alpha plus beta is 1 by 4, alpha into beta is minus 1. Just simply have to substitute in the formula. So write k as usual, that is k into, so x square minus alpha plus beta. Alpha plus beta value is 1 by 4. That is 1 by 4 into x, 1 by 4 into x plus alpha into beta. Alpha into beta is minus 1. So substitute minus 1. So see here, just we have substituted, just I have substituted alpha plus beta is 1 by 4, alpha into beta is minus 1. So just we have to simplify. So is equal to k into, so it becomes x square. So 1 minus 1 by 4 into x, it becomes x divided by 4. So plus into minus is minus 1. K into x square minus x by 4 minus 1. So further we have to simplify here. We can get k into, so find LCM 4x square. Find LCM 4x square minus x minus 4 divided by 4. So just we have to find LCM here. 4 is the LCM. So here x square by 1 is there. So 1 x square into 4, 4x square minus x minus 4 we get. So this is the required quadratic polynomial. So if we substitute k is equal to 4, then 4 gets cancelled, we can get the quadratic polynomial. See here, if k is equal to 4, if k is equal to 4, then quadratic polynomial is equal to 4 into 4x square minus x minus 4 divided by 4. So 4 gets cancelled. Finally we can get 4x square minus x minus 4. So this is the required quadratic polynomial, 4x square minus x minus 4. So when k is equal to 4, so this is the required quadratic polynomial. By substituting k is equal to 1, 2, 3, 4, we can get different quadratic polynomials with the sum of the zeros 1 by 4 and the product of zeros minus 1. So this is the first bit. Like this we can find the quadratic polynomial when he gives the sum of the zeros and the product of the zeros. So simply you have to remember, if he gives the sum of the zeros and the product of the zeros, then the required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So just simply have to substitute alpha plus beta and alpha beta values to get the required quadratic polynomial. So this is the first bit in the second problem. Next we have to solve the second bit. This is the second bit in the second problem. Root 2 comma 1 by 3 is given. So root 2, sum of the zeros is root 2, product of the zeros is 1 by 3. Using these two we have to find the quadratic polynomial. So we know if he gives a sum of the zeros and product of the zeros, then the required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So this is the formula. Simply have to substitute in the formula. So see here, sum of the zeros alpha plus beta is equal to root 2. Sum of the zeros is root 2 and the product of the zeros alpha into beta is 1 by 3. So this is the formula. So required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So here k is constant. So we have alpha plus beta is root 2, alpha into beta is 1 by 3. Simply have to substitute in the formula to get the quadratic polynomial. So now I am substituting. See here, write k into, so x square minus alpha plus beta is root 2. So I am writing root 2 into x is there. Alpha plus beta is root 2 into x plus alpha into beta. So alpha into beta is 1 by 3. So just write 1 by 3. So k into x square minus root 2 into x plus 1 by 3. So find LCM. 3 is the LCM here. We can get, so 3 is LCM. We can get 3x square minus 3 root 2 into x plus 1 divided by 3. So just here find LCM. 3 is the LCM here. So we can get 3x square minus 3 root 2 into x plus 1 divided by 3. So if k is equal to 3, then the required quadratic polynomial becomes, if k is equal to 3, then a quadratic polynomial is equal to, so I am substituting k is equal to 3. Since here the denominator is 3, to cancel I am substituting k is equal to 3. So 3 into 3x square minus 3 root 2 into x plus 1 divided by 3. So just I have substituted k is equal to 3. So 3 gets cancelled. We can get 3x square minus 3 root 2 x plus 1. So this is the required quadratic polynomial. So sum of the zeros is root 2 has given, product of the zeros is 1 by 3 has given. This is the quadratic polynomial with the sum of the zeros is root 2 and the product of the zeros is 1 by 3. So this is the second bit. So next we have to solve the third bit. This is the third bit in the second problem. Here he has given 0 comma root 5 in the third bit. So sum of the zeros is 0 and the product of the zeros is root 5. The first one is the sum of the zeros, second one is the product of the zeros. By using these two, we have to find the quadratic polynomial. So we know, so what is the formula? If he gives a sum of the zeros and the product of the zeros, then the formula for quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So that is the formula. So just we have to substitute alpha plus beta and alpha into beta values in the formula. We can get the quadratic polynomial. So here sum of the zeros alpha plus beta is equal to 0 he has given. So sum of the zeros alpha plus beta is equal to 0. Product of the zeros alpha into beta equal to root 5. Sum of the zeros alpha plus beta is 0 and product of the zeros alpha into beta is equal to root 5. Therefore the required quadratic polynomial is equal to k into, this is the formula you have to remember, k into x square minus alpha plus beta into x plus alpha into beta, where k is constant. So now I have to substitute alpha plus beta and alpha into beta values here. So here k into, right, x square minus alpha plus beta is 0. So 0 into x plus alpha into beta value is root 5. So simply substitute root 5. So now the quadratic equation becomes k into, so write x square, so 0 into x is 0. So this total term becomes 0. So here x square plus root 5 is there. Simply have to write x square plus root 5. So this is the quadratic equation. So if we substitute k is equal to 1, then the required quadratic equation is x square plus root 5. So if k is equal to 1, then quadratic polynomial is equal to 1 into x square plus root 5. So just I am substituting k is equal to 1, then the required quadratic polynomial is equal to 1 into x square plus root 5. So which is equal to x square plus root 5, x square plus root 5. So this is the required quadratic polynomial whose sum of the zeros is 0 and product of the zeros is root 5. So this is the third bit in the second problem. Next we have to solve fourth bit. This is the fourth bit in the second problem. 1 comma 1 has given. So sum of the zeros is 1 and product of the zeros is also 1. Using these two we have to find the quadratic polynomial. So we know the formula. Required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So we have to substitute alpha plus beta and alpha into beta in the formula. We can get the quadratic polynomial. So see here, sum of the zeros is alpha plus beta is equal to 1 and the product of the zeros alpha into beta and the product of the zeros alpha into beta is also equal to 1. So now we have to substitute in the formula. Required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta, where k is constant. So see here, now I have to substitute in the formula k into, so write x square minus alpha plus beta is 1. So write 1 into x plus alpha into beta is also 1. So just I have substituted alpha plus beta is 1, alpha into beta is also 1. So we can get a k into, it is x square minus 1 into x is x plus 1. So this is the required quadratic polynomial. By substituting different values for k, we can get different quadratic polynomials. So now I am substituting k is equal to 1. So if k is equal to 1, then the quadratic polynomial is equal to 1 into x square minus x plus 1. So I have substituted k is equal to 1 here. So we get x square minus x plus 1. So this is the required quadratic polynomial whose sum of the zeros is 1 and the product of the zeros is also 1. So this is the fourth bit in the second problem. Next we have to solve fifth bit. This is the fifth bit in the second problem. Minus 1 by 4 comma 1 by 4 is given. Sum of the zeros is minus 1 by 4 and the product of the zeros is 1 by 4. So using these two we have to find the quadratic polynomial. So we have quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So alpha plus beta is sum of the zeros, alpha into beta is product of the zeros. So he has given both the values. Just we have to substitute in the formula to find the quadratic polynomial. So see here minus 1 by 4 comma 1 by 4. The first one is sum of the zeros. So it is denoted by alpha plus beta is equal to minus 1 by 4. And the second one is product of the zeros. It is denoted by alpha into beta. So he has given it is as 1 by 4. So these two values we have to substitute in the formula. Then required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta, where k is constant. So now we have to substitute alpha plus beta and alpha into beta in the formula. So see here k into x square minus alpha plus beta is minus 1 by 4. So I am substituting minus 1 by 4 into x plus alpha into beta value is 1 by 4. So I am writing 1 by 4. So just we have to simplify here k into, so here x square minus into minus plus 1 into x is x by 4 plus 1 by 4. So find LCM here. So k into, we get 4x square plus x plus 1 divided by 4. So this is the required quadratic polynomial. For different values of k we can get different quadratic polynomials. Since the denominator is 4, I am substituting k is equal to 4. So if k is equal to 4, then quadratic polynomial is equal to 4 into 4x square plus x plus 1 divided by 4. So 4 gets cancelled. We can get finally 4x square plus x plus 1. So this is the required quadratic polynomial whose sum of the zeros is minus 1 by 4 and the product of the zeros is 1 by 4. So this is the fifth bit in the second problem. So next we have to solve the sixth bit. This is the sixth bit in the second problem. Totally there are 6 bits. This is the last bit. So it has given 4 comma 1. So sum of the zeros is 4 and the product of the zeros is 1. So using these two we have to find the quadratic polynomial. So we have quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So that is the formula. So he has given alpha plus beta is 4 and alpha into beta is 1. Simply you have to substitute in the formula to get the quadratic polynomial. So here sum of the zeros alpha plus beta is 4. So first one is the sum of the zeros and the product of the zeros alpha into beta is 1. So required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta, where k is constant. So now we have to substitute alpha plus beta and alpha into beta in the formula. So see here I am substituting k into, so x square minus alpha plus beta is 4. So 4 into x plus alpha into beta value is 1. So simply we get k into x square minus 4x plus 1. So this is the required quadratic polynomial. For different values of k, we can get different quadratic polynomials. So if k is equal to 1, then the required quadratic polynomial becomes, if k is equal to 1, then the required quadratic polynomial is equal to 1 into x square minus 4x plus 1. So it is equal to x square minus 4x plus 1. So this is the required quadratic polynomial with sum of the zeros is 4 and the product of the zeros is 1. So this is the sixth bit in the second problem. Totally there are 6 bits. All the 6 bits we have completed. So that's all today's class. We will meet in the next class with another problem. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from Polynomials exercise 3.3, third problem. So see here what he has given. Find the quadratic polynomial for the zeros alpha comma beta given in each case. So this is first bit. Totally there are 4 bits in the third problem. So this is the first bit 2 comma minus 1. So it is alpha is equal to 2, beta is equal to minus 1. So he is asking to find us the quadratic polynomial. So in the second problem he has given alpha plus beta and alpha and beta values. He is asking to find us the quadratic polynomial. But here he has given directly alpha and beta values. He is asking to find us the quadratic polynomial. So see here how can we find. So here given alpha is equal to 2, alpha is equal to 2 and beta is equal to minus 1, beta is equal to minus 1. So I have to find alpha plus beta. Alpha plus beta is equal to 2 plus minus 1. So that is 2 minus 1. 2 minus 1 is 1 and we require alpha and beta values. And alpha into beta is equal to, so alpha is 2, beta is minus 1, 2 into minus 1 is minus 2. So alpha plus beta is equal to 1, alpha into beta is minus 2. So next quadratic polynomial, required quadratic polynomial is equal to, so this is the formula. Required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So we have alpha plus beta is 1, alpha into beta is minus 2. We have to substitute in the formula. So that is k into x square minus alpha plus beta is equal to 1. So simply we have to substitute 1 into x plus alpha into beta value is minus 2. So substitute minus 2. So k into x square minus alpha plus beta is 1 into x plus alpha into beta is minus 2. So now I have to simplify it. K into, it becomes x square minus x minus 2. So here we have to write where k is constant. K is equal to what? K is constant. So this is the required quadratic polynomial. For different values of k, we can get a different quadratic polynomials. Now I am substituting k is equal to 1. So if k is equal to 1, then quadratic polynomial is equal to 1 into x square minus x minus 2. That is x square minus x minus 2. So this is the required quadratic polynomial whose zeros are 2 and minus 1. x square minus x minus 2. So this is the first bit in the third problem. So next we have to solve second bit. This is the second bit in the third problem. Root 3 comma minus root 3 has given. First one is alpha and the second one is beta. So he has given alpha and beta values. He is asking to find as the quadratic polynomial. So we have quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So here just we have to substitute alpha plus beta and alpha into beta in the formula. But here he has given only alpha and beta values. We have to find alpha plus beta and alpha into beta. So alpha is equal to root 3, beta is equal to minus root 3. So find alpha plus beta. So alpha is root 3 plus beta is minus root 3. Root 3 plus minus root 3. So plus root 3 minus root 3 gets cancelled. Alpha plus beta is equal to 0. So and alpha into beta is alpha is root 3 and beta is minus root 3. So root 3 into minus root 3 we can get minus 3. Here minus 3. So required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. K is constant. So we have alpha plus beta is 0. Alpha into beta is minus 3. Just we have to substitute in the formula. So here is equal to k into x square minus alpha plus beta is 0 here. So 0 into x plus alpha into beta is minus 3. So substituting minus 3. So it is k into x square. So 0 into x is 0. Totally it becomes 0. Here plus into minus, minus 3. So this is the required quadratic polynomial k into x square minus 3. But we can get different quadratic polynomials for different values of k. So now I am substituting k is equal to 1. If k is equal to 1, then the required quadratic polynomial is equal to 1 into x square minus 3. So 1 into x square minus 3 is equal to x square minus 3. So this is the required quadratic polynomial whose zeros are root 3 and minus root 3. So this is the second bit in the third problem. Next we have to solve third bit. This is third bit in the third problem. 1 by 4 comma minus 1 has given. Alpha equal to 1 by 4. Beta equal to minus 1. So he is asking to find us the quadratic polynomial. So the required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. This is the formula. So to find the quadratic polynomial, so here he has given alpha equal to 1 by 4 and beta equal to minus 1. We have to find alpha plus beta, that is 1 by 4 plus minus 1. So find LCM, we can get 1 minus 4 by 4, that is minus 3 by 4. So alpha plus beta is equal to minus 3 by 4. Alpha into beta is 1 by 4 into minus 1, that is minus 1 by 4. Minus 1 by 4. So this is the quadratic polynomial formula, k into x square minus alpha plus beta into x plus alpha into beta. K is equal to constant. Now we have to substitute alpha plus beta is minus 3 by 4. Alpha into beta is minus 1 by 4. So now I am substituting k into x square minus alpha plus beta is minus 3 by 4. So write minus 3 by 4 into x plus alpha into beta is minus 1 by 4. So write minus 1 by 4. So just I have substituted alpha plus beta is minus 3 by 4 and alpha into beta is minus 1 by 4. So again simplify here, k into, it is x square minus into minus plus 3 into x is 3x by 4. Here minus into plus is minus 1 by 4. So find LCM, we get k into, so 4x square plus 3x minus 1 divided by 4. So this is the required quadratic polynomial. For different values of k, we can get the different quadratic polynomials. If k is equal to 4, see here we can get if k is equal to 4, then the quadratic polynomial is equal to 4 into 4x square plus 3x minus 1 divided by 4. So to cancel with 4, I have substituted k is equal to 4. So now this is the required quadratic polynomial, 4x square plus 3x minus 1. 4x square plus 3x minus 1 is the required quadratic polynomial whose zeros are 1 by 4 comma minus 1. So this is the third bit in the third problem. So next we have to solve fourth bit. This is the fourth bit in the third problem, 1 by 2 comma 3 by 2. So here alpha is 1 by 2, beta is equal to 3 by 2. So he has given alpha and beta values. He is asking to find us the quadratic polynomial. So here we have the required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta. So here alpha is equal to 1 by 2 and beta is equal to 3 by 2 he has given. We have to find alpha plus beta. So that is 1 by 2 plus 3 by 2. So we can get 1 plus 3 is 1 plus 3 divided by 2, that is 4 by 2 is 2. So alpha plus beta value is 2 and we have to find alpha into beta. So alpha value is 1 by 2 into beta value is 3 by 2. So 1 into 3 divided by 2 into 2. So 1 into 3 is 3, 2 into 2 is 4. So alpha plus beta is 2, alpha into beta is 3 by 4. So now required quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha into beta where k is constant. Now we have alpha plus beta is 2, alpha into beta is 3 by 4. We have to substitute in the formula. So see here k into x square minus alpha plus beta is 2 into x. So alpha plus beta value is 2 into x plus alpha into beta value is 3 by 4. So just I have substituted alpha plus beta and alpha into beta. So now I have to substitute, we have to simplify here, x square minus 2x plus 3 by 4. X square minus 2x plus 3 by 4. Find LCM. So here k into 4 is the LCM. We can get 4x square minus 8x plus 3 divided by 4. So here 4 is the LCM. 4 into x square, 4x square, 4 into minus 2x, 8x plus 3 divided by 4. So this is the required quadratic polynomial. For different values of k, we can get a different polynomials. So now I am substituting k equal to 4. Since the denominator is 4, I am substituting k is equal to 4. If k is equal to 4, then quadratic polynomial is equal to 4 into 4x square minus 8x plus 3 divided by 4. So just I have substituted k is equal to 4. So 4 gets cancelled. Finally get 4x square minus 8x plus 3. So this is the required quadratic polynomial whose zeros are 1 by 2 and 3 by 2. So this is the fourth bit in the third problem. So this is the fourth bit. So there are totally 4 bits. We have completed all the 4 bits. So that's all today's class. We will meet in the next class with another problem. Thanks for watching. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from Polynomials exercise 3.3 fourth problem. See here what he is asking. verify that 1 comma minus 1 and 3 are the zeros of the cubic polynomial x cube minus 3x square minus x plus 3, and check the relationship between zeros and coefficients. So very important. So see here, let p of x is equal to x cube minus 3x square minus x plus 3. So he is asking to show that 1 minus 1 and 3 are the zeros of the given polynomial. So how can we show? By substituting 1 minus 1 and 3 in p of x. If we get p of 1 equal to 0, p of minus 1 equal to 0 and p of 3 equal to 0, we can say that 1 minus 1 and 3 are the zeros of the p of x. So next he is asking to check the relationship between the zeros and the coefficients. So first we have to find, first we have to verify whether 1 minus 1 and 3 are the zeros of p of x equal to x cube minus 3x square minus x plus 3. So let p of x equal to x cube minus x square minus x plus 3. So substituting x is equal to 1 in p of x. So p of 1 is equal to, so if we substitute x equal to 1, p of 1 is equal to x cube is 1 cube minus 3 into x square is 3 into 1 square minus 1 plus 3 is equal to, so 1 cube is 1 into 1 into 1 1 minus 3 into 1 square is 1 and minus 3 into 1 is 3 only. So here minus 1 plus 3. So here 1 plus 3 is 4, minus 3 minus 1 is also 4. 4 minus 4 is equal to 0. This is p of 1. So next we have to substituting x is equal to minus 1. So we get p of minus 1 is equal to, so in p of x wherever x is there, write x equal to minus 1. X cube, that is minus 1 whole cube minus 3x square, 3 into minus 1 whole square minus x is there, minus of minus 1 plus 3 is equal to, so minus 1 whole cube is minus 1, so minus 3 into minus 1 whole square is plus 1 only, so minus of minus 1 plus 1 plus 3. So just you have to simplify. So see here, it is a minus 1 whole cube is minus 1. So this is minus 3 into minus 1 whole square is plus 1, minus into minus plus 1, here plus 3. So here minus 1, here minus 3 into 1 is minus 3, minus 1 minus 3 is minus 4, here 1 plus 3 is plus 4. So minus 4 plus 4 is also 0. So this is p of minus 1. So next we have to substitute x is equal to 3 in p of x. So substituting x is equal to 3 in p of x, we get p of 3 is equal to, p of 3 is equal to, so in p of x wherever x is there, write 3. So x cube is there, it is 3 cube minus 3x square is there, 3 into 3 whole square minus x is there, that is minus 3. So here plus 3 is there, is equal to, so here minus 3 plus 3 gets cancelled. 3 cube is 3 into 3 into 3, we can get 27 minus 3 into, here 3 square is 9, 3 square is 3 into 3, 9. So here 27, 3 into 9 is also 27, 27 minus 3 into 9 is also 27 is equal to 0. Therefore we have p of 1 equal to 0, p of minus 1 equal to 0 and p of 3 equal to 0. So here we can write since p of 1 equal to 0, comma p of minus 1 equal to 0 and p of 3 is equal to 0, therefore we can say zeros of are the zeros of p of x, zeros of p of x. So since p of 1 equal to 0, p of minus 1 equal to 0 and p of 3 equal to 0, therefore 1 minus 1 and 3 are the zeros of p of x. Therefore we have verified that 1 minus 1 and 3 are the zeros of p of x. So in the next he is asking to check the relationship between the zeros and the coefficients. So now we have to check the relation between the zeros and the coefficients. So for that we have to compare this p of x by ax cube plus bx square plus cx plus d. So we can get the coefficients. See here, comparing p of x, we get, so here we have to compare by ax cube plus bx square plus cx plus d. Here a is the x cube coefficient, here x cube coefficient is 1, therefore a is equal to 1. So here b is x square coefficient, here x square coefficient is minus 3, b is equal to minus 3. Here c is x coefficient, here x coefficient is equal to minus 1, therefore c equal to minus 1. And here d is the constant, here constant is 3. So next let the zeros. So zeros are alpha, beta and gamma. Let zeros alpha is equal to 1, comma beta equal to minus 1 and gamma is equal to 3. So then we have alpha plus beta plus gamma is equal to minus b by a. Alpha beta gamma, alpha into beta into gamma equal to minus d by a. Alpha beta plus beta gamma plus gamma alpha equal to c by a. So now we have to check the relation. First one, sum of the roots alpha plus beta plus gamma is equal to, so alpha value is 1 plus beta value is minus 1 plus gamma value is 3. So 1 plus 1 minus 1 gets cancelled, it is 3. So 3 I am writing as minus of minus 3 divided by 1. So see here this minus of minus 3 here. So that is minus b by a, minus b by a. So minus is there, here b equal to minus 3. So here also b equal to how much? Minus 3. So a equal to 1, here also a equal to 1. Therefore alpha plus beta plus gamma equal to minus b by a. So next second one, we have alpha into beta into gamma is equal to alpha into beta into gamma. Alpha value is 1, beta value is minus 1, gamma value is 3. So 1 into minus 1 into 3 we get minus 3. So that is minus 3 I am writing as minus 3 divided by 1, that is minus d by a, minus d by a. So minus d is equal to how much here? 3. Yes, d is equal to 3, a equal to 1. Here also a equal to 1. So this is alpha into beta into gamma. So we have one more, alpha into beta plus beta into gamma plus gamma into alpha is equal to, alpha value is 1 into minus 1 plus minus 1 into 3 plus 3 into 1. So we have alpha beta, that is 1 into minus 1 plus beta gamma minus 1 into 3 plus gamma alpha 3 into 1. So 1 into minus 1 is minus 1, minus 1 into 3 is minus 3, 3 into 1 is plus 3. So here minus 3 plus 3 cancelled, we have minus 1 divided by 1. So it is c by a. So see here c value is minus 1, a value is 1. So therefore verified, we have verified the relationship between the zeros and the coefficients. So this is the fourth problem in the third 3.3 exercise. So we have completed all the 4 problems. That's all today's class. We will meet in the next class with another problem. Thanks for watching.